Here is a trigonometric identity that we are required to prove. The left side of the equation is a fraction where the numerator is sine cube x plus cos cube x divided by sine x, and the denominator is sine x plus cos x. And the right side is 1 minus sine x cos x. Now, in general, what I would recommend for proving any trigonometric identities is to change all the trig functions to sines and cosines. If you see cosecant, secant, tan, and cot, change them to sines and cosines. And then remember the Pythagorean identity, cos square theta plus sine square theta equals 1. And then the difference of squares formula is a minus b, a plus b equals a square minus b square. And then again, there is one other algebra step I want you guys to remember is when you have to add two fractions or even subtract, then you can take the common denominator. But a faster way is to cross multiply AD plus BC. That becomes the numerator, and then the denominator is simply the product of the denominators. If you have to subtract A over B minus C over D, then it's AD minus BC over BD. So these are general recommendations that you need to know whenever you solve a trigonometric, whenever you're trying to prove a trigonometric identity. Now, for some problems, you may need to do more than just this. And for this particular problem, where you are trying to prove this, and I see that there is a sum of cubes. So there is a formula for sum of cubes in algebra. If you remember that, that's great. If not, I'm going to write it down. You can always factor a cube plus b cube, and that factors as a plus b times, now it's going to be a square minus ab plus b square. If you have seen this earlier, then that's good. If not, please take a note of this factorization. And now that we talked about sum of cubes, let's also talk about difference of cubes. Earlier we looked at difference of squares formula, a square minus b square. Now here we are talking about difference of cubes. So this looks somewhat like the one above. For a cube plus b cube, there is a binomial factor of a plus b. Here there will be a binomial factor of a minus b. And then there was a trinomial factor here, a square minus ab plus b square. There will be a trinomial factor here also, but this time it would be a square plus ab plus b square. Now you can actually prove it by simply distributing this a into all of that and then minus b into all of that, and then collect all the like terms. You'll see that you get a cube minus b cube. Now, this formula is not needed, but we need this formula. So let's start with our proof. What's the left side? The left side is a fraction where the numerator is sine cube x plus cos cube x, and the denominator is sine x plus cos x. Now we can rewrite this. The numerator is sum of cubes, so I can use this formula. So a is going to be sine x and b is going to be cos x. So I have sine x plus cos x, and then there is a trinomial factor. A square is sine square x minus ab is sine x cos x plus b square is cos square x. And the denominator is just sine x plus cos x. Now notice that I have this up here. So there is a common factor. I can cancel the common factors in numerator and denominator. And notice that's the only thing left. I mean, if you want, you can write a 1 here, but there's no fraction anymore. Now it's just sine square x minus sine x cos x plus cos square x. And notice sine square x plus cos square x is just 1. So I can combine these two and say it's 1. So I have 1 minus sine x cos x, which is the same as the right side. So we started at the left and arrived at the right. So we proved it.